Yep, I am live. Okay, chalo. So, hey guys, welcome to yet another Digit Squad Friday AMA live. This one's going to be around laptop and desktop maintenance, mostly from a software as well as a hardware perspective. We're just going to wait for a while for more people to sort of join in on the stream and get started in about 2 to 3 minutes. Till then, you can obviously put down your comments. We'll get to those towards the end of the session. Uh, Also, maybe perhaps you need a little introduction for the people who are joining us on the stream for the very first time. This is something we do every week, at least we aim to do every week. We basically give out the survey of topics that you guys would be interested to watch us or hear us speak on, opine on, and on the basis of whatever you guys pick, we decide to hold a nice AMA, probably pick up a nice presentation and all. This week's topic happens to be laptop and desktop maintenance. That's what you guys wanted to know about, and that's what we'll be doing. Previously, we've done stuff like how to review PC gadgets, how to review mobile phones, then what all things should you keep in mind while you're trying to run a blog, and similar topics exist. Basically, you can ask us anything in the whole domain of technology, as long as consumer tech, as well as a little bit of coding, perhaps gadgets. Very much so. We have plenty of in-house expertise around reviewing gadgets, talking about gadgets, opining, maintaining, and repairing those things. And aside from that, you can always hit us up in the DigitSQUAD app. We're always sitting there idle and doing absolutely nothing. So you can speak to us, bother us, or you can bother Tarun and Arun about these things, and they'll get in touch with us so we can respond if you have any important queries. Um, I think we've waited enough for people to join in. So let's begin. Like I basically mentioned, this is going to be an overview of what all you should be doing while you're trying to, let's say, troubleshoot your PC, and also what steps you should take in order to ensure that things won't, get worse later on. So first, we're going to look at both the hardware and software perspectives. The hardware, obviously, with finished goods like laptops, mobiles, and all these things, it's kind of difficult to disassemble. And even if you do manage to disassemble, the depth of knowledge required to actually troubleshoot the different aspects of electronics device, especially these days, you don't even have schematics being given out by manufacturers, be it laptops, mobiles, or desktops. So it becomes kind of difficult to identify and figure out what's wrong unless you happen to be an avid reader or of technology articles and all those things, and or let's say you watch a lot of YouTube videos around people who maintain, repair, and fix these things. Moreover, it's kind of expensive, even if you do manage to troubleshoot and identify exactly what's wrong with your hardware, to fix it, especially given that often you have to replace entire modules altogether. So if let's say one particular IC on your RAM module is gone, then you have little choice rather than replacing the entire thing. You can't go to a repair shop and ask them to desolder a BGA grid IC and then find the exact same IC from the exact same batch and replace it, because even if you do find a memory IC, it's not going to be compatible, especially in the memory segment, because you have every single production run lasting for barely a few weeks, and the schematics change because there are improvements made into the IC, what do you call, electronics. So getting the exact same product is difficult, and if you do manage to get it, the hardware required to replace it is even more expensive. So that's why often when you're troubleshooting hardware, you are left with no option but to replace the entire thing. Your RAM's gone, replace the damn thing. Your motherboard's gone. Maybe you can find components if your motherboard is fairly recent and the component in question happens to be a common thing. So the BIOS ICs are common, your ports and everything are common. The ICs, on the other hand, they will be available for roughly 3 to 4 years after manufacture, after which it's going to be difficult to get those particular ICs. You might find them on AliExpress, Banggood, or even the American eBay. Uh, India doesn't have an eBay anymore, so these sites tend to have replacement parts for really, really long periods of time. So basically, anything around with hardware, you need to have a lot of information already, and you need to have good skills of finding exactly what's wrong, and then you have a tedious process of finding the product, buying it, and then getting it replaced. Software, on the other hand, it's very easy to resolve. You have umpteen number of posts online in different forums, on different websites. If it's a common issue, sites like ours will cover it, and solutions can be easily found. But the thing is, with software, you have multiple layers, and therein comes a similar level of complexity that we've seen in hardware. So, with, let's say, if something's not booting properly on your PC, then uh, a lot of things, the scope for a lot of things to go wrong. It could be in your BIOS, it could be in, let's say, the kernel level drivers, it could be in the OS DLL files, it could be in your hardware, whatever you install, the software that comes along with the drivers, and then you can have multiple applications. Things break all the time, especially when you're looking at Windows. Of, let's say, the last couple of years, every major Windows update tends to break a lot of things. Like recently, it knocked off a lot of internet adapters. So if you happen to be one of the unlucky ones with that particular Realtek chip, then your internet connection would be very spotty. Same thing happened with webcams as well. One of the Windows updates knocked out all webcams of a certain manufacturer. So problems can occur. The solutions for them sometimes will not be easy to find. Downgrading to a previous version of the software is often an easy to uh, implement solution, but the thing is, you end up losing a lot of work unless, of course, you take regular backups. So that being said, we're going to look at some of the tools that are very easy to obtain, often cheap as well, and would be most commonly used in the process of troubleshooting your PC and laptop. So number one is kind of the obvious thing. It's a screwdriver kit. The one we've pointed out over here happens to be a Jacome JM8172. It's available in India, which is why we picked this, and it has a lot of bits, I believe around 115 or so. Why these bits matter is because we've often seen laptop manufacturers, especially, and smartphone manufacturers tend to use these exotic bits, like the pentalobe ones, or the triangle bits with the little key in the center. These bits are not found in most screwdrivers, and you require some of the expensive ones. Even if you just require one bit, you often can't purchase that bit solo. You have to get a kit which comes with a similar set of bits, like 115, 120. And the benefit of getting a kit like this is it has multiple things which are kind of useful. Like this one has a screwdriver with a nice pivot ring at the top that makes very easy for you to move multiple screws. That's somewhat of a luxury for people like us. Then you have tweezers, which are useful if you're sort of navigating within a myriad web of wires. If you've opened up desktop, you wouldn't find such a bundle of wires, because everything is airy and you don't need to manage space and perform tight configurations. But when you open up a laptop, on the underside you have different layers in which the cabling is managed. So if you open the first shell, you'll find maybe 3 to 4 cables. Once you remove those cables, remove the battery, remove the hard drive and all, you'll find another layer of cables. Sometimes the connectors of these FRC cables happen to be kept in some nook or cranny which your fingers are too stubby to get to. In such cases, a tweezer helps. And then you have some tools called such as the spudger. Now that spudger is basically a wedge, a very thin wedge that is made out of strong material. So let's say if you find an object that has no visible screws on the side, most of the times it's locked together by means of clips on the inside, plastic clips, and sometimes they're glued together. If they're glued together, you have little choice. You can either use a hair dryer to sort of heat the glue, release that, and then pull it apart using a spudger. Or if it's just clips, then using a credit card or using a spudger, you can sort of edge into the crevice and then separate the entire thing. And another important thing that we like about kits like these is one of the halves tends to have a little grid structure on the inside, so it's very easy to arrange and manage screws once you've removed them. Typical laptop, if you want to service, let's say, just the battery, you're going to remove about 12 to 20 screws minimum. 12 to 20 screws of different dimensions, all that too. Usually what happens is it's some sort of standard that they follow. When you have screws in a laptop, it's going to be an M3, M4, M5, but the thing is the length of the screws happens to be different. So the edges will have thicker screws which are M4s perhaps, but towards the internals you'll have way thinner screws, and then you have different varying lengths. If you let's say use a longer screw in a hole which requires a shorter screw, then your screw might protrude inside and then end up cracking something that shouldn't be touched, or you might get a short circuit. So keeping in mind exactly which screws you've removed and where they went is very much important when you're servicing any component, be it a laptop or be it a finished desktop. So a good thing that these kits tend to have is the little tray on the bottom, which allows you to manage the screws properly. And if possible, you can also get a magnetic mat. So magnetic mats, especially the ones that are designed for troubleshooting, tend to have a nice little grid structure painted on them, so you can arrange them and the screws stay in place even if accidents happen. So that's one part. Then you have a multimeter. Now this is sort of for people who are fiddling with the hardware and not much with the software. Now, the most important tool within the multimeter happens to be the continuity check. The continuity check allows us to figure out if cables that are all winding and long within a certain circuit happen to be intact. Let's say you have a power circuit that's running from point A to point B with a lot of different things in the center. If you want to ensure that your connection happens to be from one end to the other, then the connectivity, or sorry, continuity check tool within the multimeter is very helpful. Also, there are little what do you call ammeters as well as voltmeters built into the multimeter. If you happen to find a schematics diagram of let's say your laptop or your motherboard or anything that you're trying to replace, then the schematics will have different voltage points. That is, if you, let's say, place the ground of your multimeter on the ground and then point your red pin onto these particular points, these voltage points, then you have the proper voltage that's supposed to be present whenever these devices are functional. So let's say between your two RAM modules, you have this particular resistor, and that happens to be a voltage point which says the voltage at this level is going to be 1.3 volts. So if you use a multimeter at that particular diagnostic voltage point, it'll tell you it's 1.3 volts or within, let's say, a plus minus 10% variance. If that's there, then let's say you can easily mention that this thing is working fine. You can move on to the next diagnostic voltage point or perhaps trace back. But let's say if the voltage is wrong, then obviously you know something's wrong at that particular point. So the multimeter is very helpful when you're trying to diagnose hardware faults, but not so much when you're working around with software, kind of obvious, right? Then you have isopropyl alcohol, the one tool that helps you clean electronics easily without causing any shorts. Along with isopropyl alcohol, obviously you should have some lint-free cloths and some earbuds. Johnson & Johnson, anything, doesn't matter. Basically, the cotton should not come off. When you're cleaning copper contacts and gold contacts, isopropyl alcohol tends to get the job done easily and quicker, even if you have nasty stain and oxidation stains. But one thing you should keep in mind is isopropyl alcohol is also uh, kind of nasty when you are looking, when it gets in touch with plastics. These are a certain type of plastics. In most laptops, desktops, or whatever, the manufacturers are smart enough to use plastics which do not react with isopropyl alcohol, because even they use isopropyl alcohol to perform all the cleaning. But if you're getting cheap goods, extremely cheap built material, then the plastics could not be of the proper grade, and you might have nasty reactions when you have isopropyl alcohol coming into the mix. Usually the thing warps and bends and turns into a gloop. So if you are planning on using isopropyl alcohol near anything that is plastic in nature, it's always nice to use a small cotton tip earbud and then dip it into the isopropyl alcohol and perform a small test in some corner, some nondescript corner, where you can just observe for, let's say, around 10 to 15 minutes if there's some discoloration, or if there is warping or the plastic softens. Discoloration might not be exactly the correct thing, because it might end up cleaning the spot and you might have a cleaner area. So that kind of discoloration is obviously excluded. The fourth tool that we have is a Linux Live Boost. It's supposed to be boot USB stick. So you can pick any Linux. Mostly people tend to go with Ubuntu, Mint, Manjaro. These things allow you to eliminate the operating system and most of the Windows based drivers from the troubleshooting process. So let's say you have something going wrong with your PC and you're trying to figure out exactly what whether it's the software fault or the hardware fault. A very easy, simple way to do that is just to live boot Ubuntu on a stick or any Linux distro, and if all your hardware happens to work properly without any issues, then it's something to do with your software, that is your Windows installation or any of the applications and drivers and all things installed. Lastly, this happens to be a very important part, that's common sense. Often people tend to not look at the most obvious errors in front of their eyes. Simple example would be, if something went wrong, it's 99% related to what was performed right before what went wrong. So if you installed a new piece of hardware and your PC doesn't boot, 90% it's going to be the new piece of hardware that you installed that was the problem. And often what you need to take into account is that certain software are set to auto update. Now this is often disregarded when people are trying to troubleshoot the systems, because it's not clearly visible, it's not on the top of your mind. And if you happen to have a schedule, or if you fixed in your mind that anything that you're installing on your PC, you're only going to let it update on a certain schedule, let's say 2 p.m. on so and so date, or perhaps 2 a.m. if you want to not disturb your day cycle, then if your problem appears on the next day, the very first thing you should try to figure out is what new things were installed on your PC in the latest update cycle, because often that could be a problem. And if you have, let's say, update number, let's say you recently got a Windows update, there'll be some knowledge bank ID, there's a KB, and then some numbers associated with it. Just Google that number. Often in the next 8 to 9 hours, if the problem has been identified and if a lot of people have been affected by this particular problem, then there'll be news articles up around this update as to this is a nasty update, it makes your things go worse, please don't install it, and then you can sort of roll back on the updates. Also, a good thing to do, especially when you're on Windows, is to defer updates, because Windows, the beta testing portion of Windows happens to be kind of finicky right now. It is wise for you to defer updates for, let's say, maybe a few months, unless these happens to be security updates. In that case, you should wait for perhaps a week or so before you get the all okay from the internets. Basically, if people are not cribbing about a certain update, it's fine, and you can go ahead and install that. So common sense part is sort of the important thing that we'll elaborate on throughout the entire process, but we also have certain flowcharts like this one. So you don't need to follow this one. This is just to sort of intimidate and screw with you guys. What we are going to be doing in order to troubleshoot anything basically with the PC, it's called the process of elimination. So you take up all the stakeholders within the system. Let's say in the case of a laptop, you have the hardware. Within the hardware, you have the monitor, the CPU, RAM, storage, the motherboard, the different internet connectivity features. Let's say, be it GSM wire, or be it the network NIC, a network infrastructure card. Then you have the IO ports on the side, and all of these things are different stakeholders. So you need to one by one eliminate these things before you can sort of move into the software portion and then figure out exactly what went wrong. Usually we tend to do the other way around. We first assume that it's going to be a software issue, because most of the time that is the problem. If it's a hardware issue, then you should have a nasty smell coming out of your PC. Mostly it's going to be burnt transistors or any other passive component. That's an easy giveaway. But coming from the flowchart, basically the process of elimination is focused on these three steps. You need to first determine the scope of the problem. That is, if let's say the display goes out, then it's not just that the monitor can be wonky. You can have the monitor, you can have the monitor's power connector, you can have the monitor's power circuitry board, you can have the monitor's data cable, then you can have the graphics card if you have a separate one. And then you can have the graphics cards ports. Some of them can be wrong, some of them can be good. Then you have the graphics cards power supply, which can be either from the board directly or it could be from the power supply. So in order to troubleshoot just one thing, that is your display not working properly, we ended up getting what, more than 10 items. So that's the scope of your problem, exactly what all can go wrong, and within that you try to identify the magnitude of the problem. That is, let's say just the cable going wrong, that's a very simple thing to replace. You can get it for $100. But let's say your power circuitry board within your monitor happens to go wonky. In that case, it's a few grand, maybe 3 to 4,000 if it's a new monitor. If it happens to be an old monitor, you're better off getting a new one altogether, because a better monitor would be around 8 to 9 grand in most cases, unless you happen to have a gaming monitor. In that case, it's depends on the features. It could be as cheap as 12K, it could go all the way up to 1 lakh, 2 lakhs and all those things. So the second step is the magnitude, and then you end up determining the source. So in the entire chain of, let's say, the same example, you don't have a display, then the problem could be at any of the different stages, right? You could have, let's say, a problem with the monitor circuitry, you could have a problem with monitor power, cable, data cable, your GPU connectors, GPU power, all these things. So how do you identify which is the problem? So all of this is sort of determined using the process of elimination. And there are a lot of flowcharts readily available on the internet for people who are not well versed with hardware and software, in order to perform this little thought process or exercise of eliminating all the things that can be at fault. Now, what you saw on the previous slide happens to be one such massive flowchart that was built. I don't know if it's from a website called If It Jams. You can search for it. It's pretty old, but the thing is, the basic concept and logic of troubleshooting things remains practically the same. So let's say you have a problem with your drive, your hard drive. Now this is an example flowchart from that, from the website called If It Jams. This was made in 2013. So you start off with the very top. Let's say your OS drive doesn't boot. That means you should most probably end up in a post screen, that is power on self-test screen, where the cursor is just blinking, and that means mostly your boot drive has not booted or is not working. Usually replacing the boot drive in such a case works wonders. But let's say something else is wrong, then let's say you use your Linux stick and then boot your Linux installation just to see if everything else is working. And using Linux, you can also attempt to sort of get into your existing boot drive and see if everything is working or not. If there are problems that you notice, you can also use this opportunity to take a backup. And it also, this flowchart, if we come back to it, let's say your OS drive boots, you move on to the branch on the right hand side. You can see if it's slow or noisy. Now with hard drives, you have this problem. Any sort of clicking noise, basically your hard drive should not be making any nasty noises, any sharp noises. It should mostly be a whirring sound, a constant noise, nothing monumental, nothing moving, momentous, anything. If it's constant, then your hard drive is usually not facing any problems. There is also something called the smart test, just basically self-monitoring test performed by a hard drive in order to report any issues or errors that it might have. Usually you can access the smart status in your BIOS, or you can also use the Linux boot drive that we mentioned, USB stick, and check your hard drive status using that to see if your hard drive is near death. In such cases, you can again take the backup and order a new hard drive and perform the replacement. Replacing a hard drive is fairly simple. You'll find plenty of tutorials online. In the case of desktops, if you built it yourself, you obviously know how to replace the hard drive. Just find whichever hard drive is wrong, remove that, pop in a new one. If you have a cloning software on the machine, then, or you could use Linux again to clone your hard drive. You can copy practically any and all data from your existing hard drive onto your new hard drive and then pop it in. This way you can sort of avoid any disturbances to your workflow. That is provided none of the data on your hard drive happens to be corrupted, and it's purely a hardware fault that is yet to affect your data. In most cases, people don't realize it quick enough, and you won't be able to salvage your OS. At least some of your operating software might also not be salvageable, and most cases your save files and anything that you have stored on, let's say, a different partition should be fine. But again, it's very random. You can't never say these things for certain, which is why we tend to sort of perform certain what do you call, hygiene actions on a regular basis, which is what we call maintenance. Also, there are certain practices that you can have in order to ensure that the fallout from a hard drive failure is minimal. That is, one is to have backups. The other thing is to not have much data that is being worked on, downloaded, or anything on the same hard drive as your OS, because the OS is the number one thing that fails. Having all your data on that one very partition is kind of silly, because if you have to format that partition, you're losing the entire thing. So common practice followed by a lot of PC users is to have your downloads folder, your documents folder, and basically anything that goes into the library structure on the left hand side and your Windows Explorer go into a different partition altogether. In such cases, all your files, everything will be on a different partition, and most certainly will be untouched unless there's a hard drive failure altogether. And your OS can be reinstalled, refreshed, and you can do a lot of things. Having a backup feature is also a wonderful thing. If you happen to have invested in a NAS device, that's a network attached to storage, these aren't exactly cheap, but you can get let's say a 2 TB NAS and all for around 14-15K. This is something you connect to your router, and you can use the software to take regular backups of certain folders on your PC. So every night perhaps, or every weekend, the NAS will basically connect to your PC. It'll power it on automatically and pull all the relevant data that has been marked for backup, and then store it. So this is a very nice practice. Even if you don't have a NAS, and let's say you have free credits for cloud servers, be it on AWS, Google Drive, or GCP, or any other service, you can manually perform this action, or you can invest in software in order to take regular backups. Usually the software that comes with NAS already has an option to sort of take a secondary or tertiary backup in a cloud storage or some other physical area. Now, in the case of hard drives, you can sometimes salvage data. Let's say if your hard drive fails, there are hard drive recovery companies that do exactly this. They'll find a particular hard drive model that's exactly as yours with the same PCB, same thing. Just move the platters into the new hard drive and then perform a recovery. It's become increasingly difficult to do the same with SSDs and any solid state media, because it's not so easy to perform the same action with SSDs. You can perform data recovery with SSDs, but not with the same ease that you could do with hard drives. So, and also SSDs tend to fail a little earlier than hard drives. Hard drives can last for decades without worry if you don't mess around with your PC, don't shut it off using, let's say, the power button and the reset button too frequently. You do everything in a graceful manner, your hard drive should last you decades. That's not the case with SSDs. SSDs usually have a warranty period mentioned on that. It's around 3, 5 to 10 years, and this is a very calculated warranty period. Your SSD will mostly fail after that period. Cheap SSDs tend to have 3 to 5 years, and just around that mark you should definitely take backups, because it's most probably going to fail, because the solid state medium, the NANDs on SSDs don't have that kind of life cycles as hard drive platters do, because they have limited read write cycles, and it physically deteriorates when you read and access the data on a regular basis. So coming back to the flowchart, you can sort of follow these steps in order to figure out exactly what's wrong and what you can do. And in most cases, let's say if your boot hard drive is affected, you will not be able to perform these steps, because you no longer have access to your OS, which is why we mentioned the Linux tool, Linux USB stick, as a tool in the required section. And like I said previously, this is a generic flowchart. This will not solve all your issues, but the most common issues can easily be resolved if you, let's say, practice certain hygiene steps, and you have certain practices which allow you to mitigate the impact of, let's say, your storage failure. Then we'll move on to RAM and CPU. So RAM and CPU, RAM tends to fail mostly around 8 to 10 years. That's what we've observed, especially if you are into the budget segment. Good modules that are designed, let's say, to run at the base clock frequencies, that's also an important thing. If you have an exotic RAM module which is kind of high end and designed to run at exotic frequencies, then those things tend to heat up a lot, and heat is an enemy of electronic devices. So if you have an exotic kit that's powered for longer frequencies and all those things will fail much earlier than the normal clocked ones, because the normal ones will not heat up as much. The normal ones are not going to work out of spec, because these things are very much what do you call, rated well within their maximum terms. Whereas in the case of exotic modules, let's say something that's like 3800 megahertz frequency RAM, which you might have in your exotic desktop, those things, because they're sort of pushing the edge of the capability of the chip, you have a higher chance of failure. So that's one more thing you can keep in mind in case you're troubleshooting your RAM. CPU, well, I've never had a CPU failing, so it's very, very difficult for CPUs to fail. One, because it's very much passive in entirety. You don't have any active components within the CPU. It's just a flat die placed upon substrate, soldered with a heat-sink metal slab on top of it. And as long as the pins underneath are not messing around and making contact with each other, you don't even have any chances of short. So good way to troubleshoot your CPU is to just remove it first, take a look underside, You can see if all the contacts are proper and shiny. Usually if you have a short circuit on your CPU, you will see a small burnt mark, and that should be an indicator exactly where the short happened. And on the consecutive, let's say, and the correlative spot on the grid, that is your CPU socket where you place it, you can see if the contacts are proper or not. But let's say you've managed to troubleshoot practically everything and you don't know whether the CPU is working or not. The number one thing you can do is take the CPU to basically someone else who has a similar board circuit, and then place the CPU in it and see if it works. This will not, in most cases, mess around with the other motherboard, because there are a lot of protective mechanisms built into motherboards these days, and that'll give you a very good indication of what exactly is wrong. And you only have to perform these steps if you end up getting a really cheap motherboard. With sort of the mid-range motherboards and the exotic motherboards, you have something called an LED indicator on top of it. Now, every motherboard manufacturer has certain codes which they use in order to let you know whether a certain component is wrong. So these BIOS codes might go by different names by different manufacturers. Asus might call it something else. Gigabyte might call it something else. Someone calls it F codes, but usually these are BIOS codes. And if you have a good motherboard which costs around 12 to 15K onwards, no matter which chipset you're looking at, this is generally the price where you get a motherboard with an LED indicator. You have these BIOS codes on it, and your motherboard manual comes with a nice glossary list of these BIOS codes. You can just look up the code to figure out exactly what's wrong. And often this helps with the process of elimination, because the code might not give you exactly what's wrong with your PC, because even the BIOS, when it's performing its power on self test, that's a post test, it goes through each component one by one before moving on to the next one. So if it got stuck at point A and your fault is at point B or C, but it has a effect on point A, then you need to solve for point A. Now that's very confusing, because even I heard it right now. So let me put it in the form of an example. Your BIOS code might say that your RAM is at fault. At this point, you can either remove the RAM and reset it and see if BIOS code improves. But the more logical and smarter thing to do would be to remove all modules, clean them, and just place one module in the base slot. The base slot happens to be the one that is furthest from your CPU, or it could be the second slot from your CPU, counting from CPU towards the outside. Now these slots are the ones where you can place practically any module and they are designed to work, because most motherboards also have something sort of a fallback feature. So if you alter the configuration of your memory modules, it's going to fall back towards the basic feature. So even if your RAM happens to be higher clocked, let's say your base clock happens to be 2133 megahertz and what you placed happens to be 3200 megahertz, if you alter the RAM configuration, it's going to fall back to the stable configuration, that is 2133. And at 2133, you're most probably going to see if or rather find out if your RAM is at fault or not. Now if you eliminate the RAM, the BIOS will run the post again, and then it will move to the next point of failure and tell you point B is now the failure, and then you resolve that, and then you resolve C. So you have to follow all these steps on the basis of the LED indicator on your motherboard. Now in case you don't have an LED indicator on your motherboard, again the multimeter, let's say if you're well versed with hardware, then the multimeter is helpful, because using that you can find out the voltage levels on the different points on your motherboard. Usually components have certain ratings mentioned right on it, like capacitors are built for certain voltage levels. So if a 12 volt capacitor is placed on a certain point and voltage line right next to it is reading 5 volts, then something's wrong. Obviously it's supposed to read 12 volts or nearly in the vicinity of that. Sometimes this will be the multimeter. In case you don't have a multimeter either, then you have no option but to go to the service center of your motherboard manufacturer and hand it in. Like we mentioned, CPU can barely ever get corrupted or messed up. What can happen is you might have overheating issues. In that case, it's not exactly the CPU that is at fault, your thermal paste that is for the uninitiated. On top of your CPU there lies a heatsink. Now between the heatsink and your CPU there is some gap. In order to fill this gap you use thermal paste. Now manufacturers are often very cheap, and what happens is after, let's say, the warranty period, the thermal paste that they use tends to dry up and develop cracks. When you develop cracks, that crack is filled up with air. Now air is a very bad conductor of heat, so essentially what happens is once the thermal paste dries up, it gets overheated, and then you have issues with the entire thing working. So once in such a case, what you do is you'll purchase thermal paste. Good heavens, someone's calling me. Disturbance. Okay, so coming back to the thermal paste, in such cases what you do is you can buy a thermal paste for about 300 to 400 bucks. You can get the Arctic Silver 5 AS5 or Cool Master Gel, these things, and then remove the heatsink from your CPU. Replace the thermal paste using the normal procedure. Usually you just drop a pea-sized droplet in the middle of your CPU and then replace your heatsink, and then perform your let's say power on self test. And some coolers, let's say the liquid coolers, tend to have RGB profiles. Now one of the things you can do with RGB profiles is that you can set it to indicate your temperature. Now let's say Corsair has something called the IQ. Using the IQ software you can set different RGB profiles for your memory modules and even for your CPU cooler. So you can set that to read the processor temperature and then set it to different colors on the basis of the temperature. So IQ right now has 3 different fields. So you can have 3 temperature ranges. 0 to 40 can be, let's say, green, then 40 to 60 can be yellow, and then 60 onwards can be red. Maybe you can alter it and move red to 80 plus, because your CPU generally idles at around 37 to 45 if you have like ambient cooling, which is 21 degrees Celsius or something like that. In India, mostly we'll have around 45 degrees. That's 40 to 45 is where you idle. And while idling, this is the optimal temperature. And obviously, anything that goes 20 degrees higher, like 60 to 70, there's something wrong in such cases. This might not necessarily be a fault with your CPU. It can also be that you have way too many applications running in the background, or let's say you have been infected with a malware that uses a CPU to mine bitcoins or some other cryptocurrency. So this is a common attack that happens, especially when you have browsers these days which are very susceptible to what do you call flyby attacks. And in such cases you often don't realize this because the performance overall is not affected. These crypto miners don't completely cripple your PC by running your CPU at 99% load. What they do is they add on to about 30% or 40% consistent load, and that is enough to drive your temperatures up, your idle temperatures up to 60-70 on a regular basis. So this could be a good indicator of exactly how why rather your CPU is performing more than it should be. By performing, I mean the temperature is higher than it should be. Oh, so that happens to be the RAM. Then we happen to speak about the CPU and motherboard as well. So I'm trying to keep this as simple as possible. We can obviously get into a lot more complexity, but that would take a lot more time. Moving on from CPU and RAM, you have the peripherals. Now, peripherals often have multiple cases of failure, like practically everything else. Now, by peripherals, I'm looking at keyboard, mouse, your webcam. Let's say you have an external network adapter that's connected via USB. All of these things can be troubleshooted in a certain manner. So Number one is you would look at the different profiles that are set. Now, mice and keyboard both have different profiles. Some of them are set to high performance, and what generally happens in this high performance is uh, the sensor. Let's take an example in this case. Let's take a look at a gaming mouse. Now, gaming mouse have different DPI levels, right? Now, most people tend to use the gaming mice basically at 800 DPI. Sensor inside a gaming mouse or mouse is capable of really high DPI levels. Common ones are around 8 to 16,000 DPI right now. Now, at that limit, your sensors are not at all accurate. The accuracy is completely off mark, and usually what happens is if you set your peripheral to a performance mode, let's say you don't know your mouse has a performance mode, and you set it, you just jack up the DPI and you find erratic movements. Even if you're trying to move it in a straightforward manner and it's jumping all over the place, that usually means that the sensor is trying to track way too many things in a short period of time, and the CPU, or rather your PC, is not reading data from your mouse at the required level. Now, that's another aspect called polling rate. Now, polling is how your processor tends to talk to each peripheral in a certain time period. Now, at higher polling rates, most devices are set to 1000 hertz. At higher polling rates, the computer is capable of pulling more data and being more accurate with your movements. But if the polling rate is lower and your DPI is high, we've observed certain gaming mice with the issue that the movement tends to be erratic. Now, this is not exactly a pronounced issue. It's when you're gaming and when you're, let's say, playing around in Photoshop and trying to place things around, and you see that your mouse is not at all accurate, it's jumping all over the place, and there's this ghosting effect where it's trying to veer off in some direction. Usually, switching to a more stable profile on your mouse or reinstalling the mouse software tends to solve this issue. Now, mice and keyboard, most of them tend to use the default Windows drivers, so drivers tend not to be an issue. But if at all you use something that is custom, that could be a problem. Now, in order to figure out whether you have a custom driver or default Windows driver, you can go to device management. Just right click on my computer anywhere and go to manage, and that will pop up your device manager. Within device manager, you can right click on your mouse or keyboard, right click again, find click on properties, and within that it'll tell you what driver is being used. If it's signed by Microsoft and the vendor is Microsoft, then it happens to be the default mouse keyboard driver that came with your operating system. In that case, most probably it's not going to be a driver, it's going to be something else. But in case it is the driver, it would be better that you go to your manufacturer's website and find an older driver, something that you know works, a previous version that you might have recently upgraded to. Again, if you upgraded recently and things went bad, then roll back. That's usually the solution. Similarly, for keyboards, you have different profiles, like more what do you call, gaming profiles. Usually in cheap keyboards, it just disables the Windows key. But in certain keys which have, let's say, lower traverse and what do you call, higher responses, I don't know, every keyboard manufacturer uses a different term. Like I happen to have an XPG keyboard, and the gaming mode in that, basically the amount of time the PC polls your keyboard for certain inputs goes up in gaming mode. So if you are, let's say, racing, or in CSGO you're trying to AD, it becomes easier for you to AD because the distance that you have to depress your key before input is registered becomes lower. This is especially correct in the case of analog keys, which are like a minority in the case of keyboards. Most of them are not analog keys, they are digital, so you only have one point of actuation. But in case you do have something in which chatter, the technical term for this is chatter, in which chatter is no longer corrected for, then you'll find erratic inputs from your keyboard. Like, let's say you're typing hi, and instead of H and I, you have 5 H's and 5 I's. So the repetition becomes too much. You can reduce that repetition. within the Windows keyboard options, but you'll notice that in certain cases with gaming keyboards, even that doesn't help. So in such cases, it's mostly the gaming profile that's on your keyboard that's at fault, because it's not correcting for the chatter at all, and chatter is basically towards the higher spectrum of your keyboard's capabilities. The same thing, same problem that we saw with DPI. Tracking at higher DPIs is nasty, whereas tracking at lower DPIs is very easy and stable. So which is why if you're, let's say, working on normal applications within your PC using a gaming keyboard and you have the gaming profile set on, you might face certain issues. Usually switching to a more stable profile will sort that issue altogether. Then obviously there are firmware. Usually Windows updates can mess up your firmware, or rather the way it was talking with your kernel, that can be messed up. So usually if you have a lot of peripherals going kaput right after a Windows update and you try to figure out this via the internet, that a lot of devices, a lot of networking adapters have gone wrong, usually there's an update on your manufacturer's website for either the software or the firmware separately. Now in the case of Corsair, you can't find the software, or rather the firmware, separate uh, for download separately. You have to use the given software, that is IQ, in order to manage all your devices. Whereas in certain cases like Logitech, the software is all you need. You don't have a separate firmware required for your webcams, because all of that is taken care of. Firmware is only required if your device is active. There is an actual microcontroller on your gaming mouse, keyboard, or peripheral. With cheap devices, you mostly don't have a microcontroller on your device. It's very passive one. Like, even with microcontrollers, you need a bit more context, because there are microcontrollers with built-in EPROMs. So the ones that can store profiles, these are the ones that tend to have more issues, whereas the ones that are very basic in nature, like practically everything has a microcontroller, like the one you find on most mice, and that just conveys the left click and right click towards your PC. It's not going to compute the clicks and try to figure out if something needs to be done with that. So anything that has a lot of customization, usually the problem can also be within the firmware. Anything that is very basic, if you get a cheap keyboard, cheap gaming mouse, your problem is not going to be mostly with the firmware, it's going to be the software that's installed or the driver that's installed. So which is why I was saying, if you have a lot of complexity, there are different layers of software, and finding the fault with which layer in the entire stack, it's a daunting task, and it's very difficult unless you happen to be on the forums and let's say you have certain RSS feeds informing you about these issues on a regular basis. So that happens to be your keyboard, mouse, and your webcam. Let's move on to monitor and graphics. So this is something we used early on in order to explain the entire situation, where we were going through the entire pipeline of troubleshooting your monitor. The problem could be with your display, the problem could be with your cables, the problem could be with the GPU, the connectors. Now, there are certain commonly found issues, like your screen can develop a slight shade of green, yellow, or red. Usually yellowing is usually associated with aging of the panel and of the backlight, in case you have some old CRT. In the case of green, which that's usually to do with, let's say, your cable going wrong, or problem could be with the buffer. Now the buffer is placed on different what do you call chips. So in case you have a high-end graphics card, buffer happens to be on the graphics card, but let's say you have integrated graphics on your CPU, then the RAM is being used as a buffer for your CPU video. So you need to keep in mind how many adapters you have on your PC in order to troubleshoot whether a certain adapter has gone wrong or not. This was more pertinent previously, because you had technologies like Optimus and also Optimus, which basically what it did was, if you had an accelerating program which required your GPU, then workload would be offloaded onto your GPU. Like right now, if you're playing a video game, then it's your graphics card that's going to take up most of the display rendering duties. Whereas if you're within your Windows environment, then your GPU is not going to be used. It's your IGP that's going to be used, that's present on your processor. But let's say you have turned on hardware acceleration. That's an option that's turned on by default in most browsers. These things, depending upon, again, the complexity in software is tremendous. Depending upon what kind of framework they have used in the website that you're visiting, the workload can be either offloaded onto the IGP or it could be offloaded onto the graphics card separately. So depending on where you're facing the issue, you can also figure out exactly what's troubleshooting. Let's say you go to a beefy website with lots of WebGL, lots of high-end graphics that's sort of making a lot of animations. Then that animation workload could be offloaded onto your GPU. And let's say when you visit this website and your graphics turns to be wonky, that means that switch has happened between your integrated graphics and your discrete graphics, and whatever went wrong can be associated with that particular GPU. That's one way of figuring out. Then you have the usual, or rather the very common screen where everything becomes garbled and you have a lot of horizontal lines. Some of them are shaded green, purple, red, blue. This is usually related with corrupt buffers and corrupt transistors and capacitors in your graphics card. Now, if you have the garbled screen, or let's say certain segments of your screen, let's say your entire screen is divided into 4 quadrants, one quadrant or a portion of one quadrant goes wrong, that's again a problem related to your buffer, which is on your graphics card, or it could be on your RAM as well. So you have two devices that can go wrong. And let's say if everything just goes wonky and you have absolutely no way of figuring out what's wrong, the primary step you should follow is just disconnect your graphics card. If you happen to have an Intel processor, then most certainly you will have an IGP. Practically everything that's launched over the last decade has an IGP. Again, in the mainstream desktop segment, in the HDD segment, you don't have GPUs. So if you remove the graphics card, this is for 90% of your people, then your PC will revert to the IGP, and then you can check whether the display is working or not. So in this case, you eliminated the GPU as being the faulty component. But let's say the problem persists. Now you need to figure out whether there is something wrong with, let's say, the IGP that is on your processor, which is going to be extremely rare, and or it could be on your RAM, which is being used as a buffer by the processor for the display. So removing sticks and just isolating one stick in the base slot is a good way of figuring out exactly something's wrong. Let's say if the problem persists even then, that's when you switch out the data cable. Now most of these active connectors like HDMI, DP, USB Type-C, all of these things rely on active circuitry in order to perform the transmission. There's a lot more things that can go wrong with active circuitry. So if you have problems, just switch out the cable. Sometimes the cable can be problematic. Even if you switch out the cable and the problem is not resolving, then grab the end of the connector and slowly wedge it in and move it in different directions. Usually this is when we are looking for short circuits or we are looking for oxidation. Now if there's a short circuit, then certain segments of your display will be wound off, as in there are numerous possibilities what can happen when there's a short circuit. Sometimes your display is completely wound off, but when you're moving the connector within the slot, and that too slowly, you are presenting different possibilities of the fault occurring or not occurring, and you can observe your display at the same time to figure out if the display is coming on, if it's off, if there's something wonky or not. Usually if this doesn't help you out, then you can always check for faults within the connector. You can take the isopropyl alcohol, use some bit of cotton buds to sort of clean the entire thing, plug it back in. Even if this doesn't help, that's when you require a secondary source. So your set-top box, if you have one at home, or if you happen to have a laptop, that's what you'd connect to your monitor, just to see if the display is being pulled in or not. And obviously you can switch the cables again just to see if the fault is with the cables or not. Even if that doesn't help, that means most probably it's your monitor that's at fault. Now if you can manage to get another monitor, let's say from your neighbor, just to test, then you can connect that new monitor to your PC just to see if the problem is with your monitor or with your PC. If the monitor works, then again you've eliminated the PC as being not being one of the problem, and the problem is primarily with your monitor. In this case, again, take it to a repair guy, or you can use the screwdriver kit to open it up, flip it around. You have the power board as well as uh, the data board. These two sections are often differentiated and very easy to figure out, because on the power board section you'll have massive capacitors to filter out the power connectors, and look at the capacitors. If they happen to be bloated on the top, that's a very good indicator that your power board is messed up. You will have to take it out to a repair guy. If you happen to have some knowledge about electronics, you can replace the capacitors and it should work. Anything that is burnt or any burnt smell, you can sort of eliminate and figure out exactly where it's coming from, and those components need to be replaced. If it happens to be an IC, then good heavens, you are out of luck. It'll be very difficult to find ICs of old displays, but even if you do, you need to find someone who has the right equipment to resolder it. Now, depending on what kind of ICs it is, if it's BGA, it's a specialist equipment that's needed. If it's a normal QFP package, then you can just use a soldering iron and solder it back on. So, this is extremely tedious. No, those were just 4 different use cases that we were going through. We didn't follow the chart exactly. What we were trying to do is follow the path of, or rather the process of elimination, and try to eliminate each and every component in the entire chain of object functioning in order to figure out exactly where the fault lies. Now, aside from this, we also looked at a lot of the software portion, especially when we're talking about the peripherals. Now, even let's say everything in your hardware is working fine, and the fault lies in your software, and you now need to figure out exactly what's wrong. Now, here are a couple of software that we found happens to be very good and very useful for performing analysis of what's wrong. Hardware info, that is number 3 on this list. It's a nice software that gives you all the what you call manufacturer info in case you need to file a report with your what you call laptop manufacturer or your hardware manufacturer for a replacement. This software will give you all the information if you can't find the box, and if let's say your PC is functioning even in a slightly partial manner. Who Crashed is a wonderful software, because each time let's say your PC crashes, be it for any reason, and you see the blue screen of death, there is a memory dump that happens. Basically everything that was in your memory, all the software, practically everything that was accessing the memory at that point in time, it gets put into a file and that's stored on your PC. Who Crashed looks at that particular log file and analyzes and identifies exactly what component went wrong. So that's going to tell you exactly which software or which driver or whatever was the point of failure, and then you can go about resolving that. Now, Ping, Netstat and ARP are different network resolution software. These are present in your PC already. These things are within your System32 folder. In case you're trying to identify whether, let's say, a certain client on your network happens to be not receiving data from your PC, you can always identify them using the ARP command. ARP is address resolution protocol. If you in your command prompt type ARP space -A, that's going to give you the entire list of all the devices that are connected to your router. So everything that has been assigned IP address by a router will be listed over there, and then you can figure out which of these devices are accounted for and which of this happens to be the one that you're trying to reach, troubleshoot. If you're trying to reach something, you can use the ping command, ping space whatever is the IP address that you obtain from ARP, and it'll give you exactly whether you can reach to that device, whether it's communicating. It'll give you the turnaround time. Netstat is for figuring out all the devices, all the software rather, that are connected to the internet at any given time. Now, let's say you are facing issues with network suites. Sometimes the issue might be with your service provider who's facing temporary downtime. Sometimes it's just a few software that's running in the background that's consuming too much bandwidth. Now, these things might not be readily apparent in front, but if you type netstat, it'll give you a list of all the things that are constantly trying to connect to different software. And if you're not comfortable with netstat ping or ARP, you can always use Microsoft sysinternals. Now, sysinternals is found on the Microsoft Store. It's a collection of multiple tools, and when you're going about looking for solutions for a lot of these problems, basically googling for things, then often one of the tools present within Microsoft sysinternals will be required at some stage or the other. This is why Microsoft sysinternals is sort of a nice collection of tools for performing all these troubleshooting tasks. Which is why we placed it right up on the top. Now, that's about it for this rather long and tedious session of troubleshooting and maintaining your PC. We focus mostly on the troubleshooting part because that's the difficult part. Maintaining in these days, your Windows OS has gotten really good at scheduling tasks on its own. Moreover, you don't need to perform a lot of the tasks which we had to in the days of hard drives, which was primarily defragmenting and looking at space allocations over and over again, because in the case of SSDs, that need is negated altogether. So maintenance on part of your PC is not so much related with your software, rather it's about your hardware. You need to clean everything, keep everything in a nice and dry place, and let's say troubleshoot using all the flowcharts that we've shown you throughout the entire session. So that's about it. Practically all the solutions that require you can Google, because 99% of all the problems are usually documented. Your problem will most probably not be visible if it's very new. Otherwise, you will find a solution. It's then up to you how you use the remaining tools that I mentioned on this page in order to troubleshoot and resolve that issue. So that's it for this particular session. This was a Friday AMA for DigitSQUAD. You will shortly be given a list of new topics. Also, you can suggest topics on your own for next week's AMA, and we'll have one of my colleagues come in and handle that particular session. So again, thank you for joining in, and we hope to see you again next week.